First, we create a new account.
Choose the username and password.
Confirm the password and security question for password recovery.
After creating an account or signing in, create a project.
This includes first the project name.
Next, the image calibration number, which is the outside diameter of the needle being used in the experiment.
We recommend that you measure the diameter of the needle with a micrometer before starting the experiment to ensure proper calibration.
Next, the differential density, which is the density difference between the liquid and its outer gas or liquid.
In this case, we are doing water and air, so we can leave it at its default value.
In case you are doing liquid in liquid measurements, example oil in water, the value will be the density of oil being used minus the density of water.
For acceleration of gravity, the default value is 9.8. If you wish to provide a more precise value, you can.
Our system supports 3 methods for calculating surface energy: Newman method, OS and good method, and the Folks method.
These 3 methods are the most widely used methods to calculate the solid surface energy.
Any of them can calculate the solid surface energy for you, however, the literature suggests that depending on the type of surface, 1 or 2 of these methods may perform better than others.
So we suggest that you first check which method is most widely used for your sample in the literature and select the same when you do your measurement.
For the purpose of this demo, we will be using the Newman method with DI water as the liquid.
Enter the surface tension value.
Select the injection mode depending on if you ordered the automatic dispenser hardware. Add-on.
Click on the newly created project and enter image capture screen.
Now put the phone inside the phone holder.
Click on the blue image capture button and adjust the distance from the needle.
We manipulate the orange box to select the area of interest.
Use the focus slider to focus on the droplet.
To get the best results, the focus slider should ideally be as close to the maximum value possible.
The aim is to be as close to the droplet as possible without losing focus.
Adjust the LED backlight and the phone's light to get the best possible contrast between the droplet and the background.
Generate a droplet as a reference.
Hit the capture button to take an image.
With smart contact points, user only needs to provide an estimate for the baseline and left-right contact points.
The system then auto-detects the exact contact points.
When selecting the baseline, be careful to not mistake the droplet for its reflection.
This can be a problem with contact angles around 90 degrees.
Hit calculate once everything is in position.
Polynomial method can measure left and right contact angles separately.
No calibration is required, unlike the Young-Laplace method.
The polynomial method works with the needle inside or outside the droplet.
The Young-Laplace method is the best method for axisymmetric drops.
It will average out the difference between left and right contact angles.
Also, the needle has to be outside the droplet.
Move the orange points to the left and right of the needle and hit calibrate.
If the calibration number is green, then the number is correct. If it's red or yellow, then something is wrong.
Generally, the lower the calibration number, the better.
If SMART fails, try extended points. It's an alternative algorithm.
Extended uses more of the droplet profile to find contact angle.
Manual method forces the measurement where the user decides.
Now we will demonstrate how to use multi-capture for dynamic measurement.
The app's multi-capture function can be used to take multiple images in a set time frame.
The maximum frames per second without an SD card in the phone is 10 FPS.
Simply specify the number of images to capture in the duration of capture.
Once you are ready, hit the capture button and start generating the droplet.
Default is smart contact points.
After completing a calculation in a series of images, the rest of the images can be automatically calculated from the project screen if all the settings were the same for each image.
A few features that can be accessed from the project screen.
The project parameters can be edited.
You can load external images into the project.
You can also run a video slideshow of the images in the project in chronological order.
The calculated data can be saved per your preference.
In settings, you can choose if you want to store the data on the SD card. You can also choose to save on your preferred cloud service.
We currently support Google Drive, Dropbox, Microsoft OneDrive, and Box.
We also allow you to easily report an issue from within the app via email.
To archive a project, long press the project and hit Archive.
Archived projects can be accessed from the Settings screen.